Outside of the abandoned asylum, a storm is brewing. We're going to create a meta sound for some wind ambience that has a random envelope on the amplitude of one of the sound elements, creating the effect of the wind getting stronger or weaker. When the wind gets strong or loud, we're going to use this to trigger another meta sound that will represent the windows of the asylum moving and rattling and squeaking because of the strong wind. In the content browser, add a new meta sound and name it MSO, MetaSound Source, CTR, Controllable, Wind Storm. Open up the MetaSound editor. Now this is going to be a continuous sound, so we can delete this one-shot interface. In our MetaSound Source menu, we've got the attenuation, and we're going to create a new one. We'll put it in the attenuations folder, and we'll call it Wind Windows. Double click to edit, and we'll give it an inner radius of 18 and a fall off of 780. In our MetaSound, we'll add a wave player. This first one is going to use Wind 02. And that's just going to be a constant kind of background wind sound. And then for our second wave player, we'll use Trees Wind 02. And on this one, we're going to apply an envelope so that it varies in volume over time. Send those to a mixer. So for this second wind sound, we're going to create a randomized attack decay envelope. So we'll start with our AD envelope. Going to produce a float, which we're going to use in the mixer in a minute. We'll create a random attack time between 0.5 and 5 seconds. And we'll create a random decay time of between 6 and 20 seconds. When the envelope's done, we want it to go around and re-trigger itself again. So we'll promote that to graph variable. We'll get a delayed version of it over here. To restart the envelope system, we'll need a trigger any, because that's going in there. We're also getting an initial trigger. Now the AD envelope is going to give us values between 0 and 1. We don't ever really want it to drop to silence, so we're going to map those numbers to a range. So we're expecting 0 to 1. We're going to map it to the range 0.2 to 1, and then we'll feed that into our gain input for that second wave player. And then, of course, we will play the wave players. We'll just add a couple of reroute nodes to make this a bit clearer. Q to align them. Okay, so we can hear this now. I'm just going to disconnect the background wind sound just so we can focus on the enveloping one for the moment. So you can hear that's got a kind of long, slow envelope on the first occasion because of the random variables that were chosen. And sometimes that attack and decay will be a bit quicker. But basically, we've got a varying wind sound there. Now what we're going to do is use that to actually trigger off another meta sound to make those windows rattle when the wind is quite high. Out of this map range float, we're going to create 2 trigger on threshold nodes. So when the wind gain goes past a value of 0.6 going upwards, we'll do something. And when it goes back down on a falling edge, this is where we want to turn our windows rattle sound off. Now for something we haven't looked at before, something that opens up a world of possibilities for audio and MetaSounds, and that is to have outputs from MetaSounds that can then control other things in blueprints. So in our Members tab, we're now going to create two outputs, and these are going to be trigger outputs. So we'll name them first Wind Strength High, and we'll make them of type trigger, and then we'll duplicate that to make the Wind Strength Low trigger output, and then we'll connect that to the trigger on rising threshold, rising edge. We'll connect that to the trigger on threshold, falling edge. So let's again play the MetaSound. This time we'll hear both of the winds, but what we'll focus on is watching these outputs. So you see there that the wind strength high actually triggered. It was quite quick. And there, the wind strength low triggered. Wind strength high again. Wind strength low. So this float that represents the volume of our audio signal is giving us trigger outputs, and now we're going to use those to actually play another MetaSound. So add a new MetaSound in the content browser. We're going to call this one MSO CTR Windows Knocking. We'll edit that, and again within the attenuation settings we'll add the same attenuation, Wind Windows. This is going to be a re-triggered one-shot system with a random delay. So here's our wave player with a random get. Let's create an array of sounds. So we'll promote that to graph variable, and we'll call that wave assets. We're going to add these Windows knocking sounds. If the wind is just gently pushing that window. Now after the trigger delay, we want that to loop round and replay the system. So we'll promote this to a graph variable, and we'll call that retrigger. And we'll get a delayed version here. I'm just holding Alt and dragging it in. Trigger any. So that both the initial play trigger and the retrigger will trigger the system. Connect these up. I've just put this multiplier in here because I know I want these sounds to be a little bit louder. You'll notice here I've left a bit of a gap, and that's because we want to use a trigger select to determine whether this on finish trigger actually goes to the random time and trigger delay and re-triggers the sounds, or if it goes to the on finished and destroys the MetaSound. We're going to use a Boolean input to control this index. We'll name it finish, make it into a bool. We attach it to that index, then it automatically converts it into an integer like we've seen before. So let's think about how we want to wire this up. If finish is false, which it is by default, then we'll get an integer of 0. So if finish is false, we want the system to continue playing. However, if finish is true, then this integer will be 1, and that's when we want to destroy the MetaSound. So let's just check that. Here's our re-triggered system. Small random delays between the sounds. Picking a new wave asset each time for our squeaky windows. Now if the Boolean input becomes true, then the next on finish that came through went to out 1 and destroyed the MetaSound. Now let's make our blueprint. So we'll add a blueprint class, child of actor. We'll call it BP Wind to Windows Rattle. So from an event begin play, we'll spawn sound at location, and we'll assign our wind storm sound to play at actor location, so get actor location. We'll promote the resulting audio component to a variable, which we'll call wind storm. Now here's the interesting bit. Right click and search for the MetaSound Output subsystem, and we'll get that. This is where we can define a particular audio component to watch in order to pick up its outputs. So from the MetaSound Output subsystem, drag out and find the Watch Output node. The audio component we want to watch is the wind storm. And the output name we're interested in here is when the wind gets louder. So if we remember, the name of our output here coming from the trigger on threshold rising is wind strength high. We'll copy that and paste that into our output name. We'll drag out from on output value change to create a custom event, and we'll call this wind up. Let's add a print string node just to check that all this is working so far. We'll attach our output name. So when we get an event, when the value changes of that output name, in other words, when this is triggered, we should get the name printed to screen. So let's go over to our window and we'll drag and drop our blueprint into the world. So there we can see on the top left, watch the screen, when the wind gets louder, passes that threshold, we should see its output name. There we go. So now we can use that to spawn our other sound, the Windows knocking sound. The spawn sound at location. Location is going to be self again, so get actor location. And it's this event that's going to play it. It's going to play our Windows knocking meta sound. And we'll promote that to a variable. Call it Windows knocking. So that's going to start our sound. And the reason I've promoted it to a variable is, of course, because we want to later act upon it in order to stop the sound with this Boolean input. So let's get another reference to that MetaSound Output subsystem. Let's watch a different output. Again, we're watching our wind storm audio component, but this time the output we're watching for is the wind strength low. Create another custom event for that. So when that value changes, we'll call this wind down. We want to use this to set the Boolean parameter on our Windows knocking audio component. And we do that with a set bool parameter or set Boolean parameter to use the full name. And the name of our Boolean is finish. Okay, and that's it. So on event begin play, our blueprint plays our wind sound. We then watch its outputs, the wind strength high and the wind strength low. And we use that to start and to stop our Windows knocking sound. So just before we try this in game, let's just go back and make sure that our defaults are set correctly. So this default here should be false so that we do get a looping system. It's very easy when prototyping and testing to set up defaults within the MetaSound, but then forget to reset them when we actually try it in game. So we'll move that up to be in the right position, close to that window. And then let's hear it. So what you should hear is that Windows knocking sound. Because the wind's quite high. Let's just offset that a little bit so we can actually see them in the game. We'll just offset the Z by 20. That just allows us to read what's going on. Just one more thing before we test it out is I've remembered that the finish Boolean parameter, in order to switch the system off, finish needs to be true. We do want to finish. So finish is true, then it goes out to 1 and it destroys the MetaSound. So there's our windstorm, and you just saw the windows knocking start to play because the value of that float obviously went above 0.6. Now it's gone below 0.6, so it's turned off that windows knocking. I'll be quiet for a moment and let you listen. So there we have it. The MetaSound Output subsystem allows us to watch outputs from our MetaSounds, and we can use those for all kinds of things. And in this instance, we're using it to actually trigger other sounds.